So section 3.5, and we're looking at finding mu and finding sigma. Now I would say, as I've said a few times in various bits of this chapter, if you're not confident with section 3.1, 2, 3 and 4, I would go back and look at those thoroughly. Don't try and plow into this. If you're just sort of watching these videos through and they're kind of making sense, stop at this point, practice everything. This section is going to be very hazily understood unless you properly understand everything else so far. Okay, so if you really feel you're ready for this, then by all means carry on. But my strong advice is make sure you understand your Z's, make sure you understand the table, the little graphs that look like this and the coloured in areas and all that sort of thing. Okay, and then if you want to come and play with section 3.5, come back to the video. So it works like this. We've got x is normally distributed, and in fact in the first example they give us mu 3 squared. The probability that x is greater than 20 is 0.2. So we think of this in the following way. We think, here is my normal distribution. The mean is some number here. I don't know what it is, but I know it's some number there. The probability that x is bigger than 20 is 0.2. So here is 0.2, and here is the number 20. Okay, so that area there is 0.2, so that means this area here is 0.8. The probability of being bigger than 20 is 0.2. Okay, I know that the standard deviation is 3, so what is the value of this mean here? Okay, so just intuitively, let's try and get an idea of it. Well, here's the mean, 0.2. Well, I know that within one standard deviation of the mean, oops, excuse me, so at mu, there's mu plus 3, mu plus 1 standard deviation, the area to the left of that is 84%. Okay, so this number that I'm looking for, that gives us a rough idea where it's going to be. So that number there is 20, so I'm looking around the sort of 17 mark. Okay, I'm looking for a number a bit bigger than 17. I've got an intuitive idea of where it should be. So the first thing is get a rough idea in your head, and that's all the stuff we're talking about in section 3.1. If you've been watching through the videos on this chapter, there's mu, there's sigma, there's little x, there's p. There are 4 things to find, and here's our first example of a question where they've given us these 2 and they've asked us to find one of mu and sigma. So if you looked at the last section, you'll know the answer is if they give us these 2, let me just say this again, feel free to skip forward 30 seconds if you have seen me say this a few times already, but I think it's an important idea. That can be a less than or equal to, a greater than or equal to. The principle is always the same. 1, 2, 3, 4 important values. If they ask us to find p or x, the answer is stick it in the calculator. If they ask us to find mu or sigma, the answer is use your capital Z's, right? So let's try that. Let's try using our capital Z's. We've got probability that x is greater than 20 equals 0.2. We've got x is distributed normally with mu and 3 squared. If we use our capital Z's, how would that work? Well, the probability that x is greater than 20 is the same as the probability, well, I've just told you to translate into Z's. How do we translate an x into Z? Take our x value, take away mu, divide by sigma. Okay. Now, the probability that Z is bigger than this is 0.2. So this is where you could go to your calculator. You could put in mu. So remember, look, we're dealing with Z here. So Z is distributed with a normal distribution 0 and 1, or 1 squared, so 1. You could go to your calculator and you could put in mu is 0, sigma is 1, p is 0.2, and you were looking for the right-hand tail, so whatever you need to do in your calculator, find the little z value. All right, so that will give you 20 minus mu over 3 equals the number that comes out of your calculator. Okay. The other option here is you recognize this as one that we can solve using this table here. So this is the probability that z is greater than or equal to little z equals p, where that's the little z and the little p in the table. So we can look up the p in the table and we get 0.8416. So 0.8416. Okay. So previously, we'd now be at an answer, right? That thing in there was just the number that we were looking for. But now that thing in there is 20 minus mu over 3. but that's all right. 20 minus mu over 3, we can deal with that. 20 minus mu over 3 equals 0.8416. If we rearrange that and solve the equation and just follow it through, it's in example 8, mu comes out to 17.4752. 3 significant figures seem sensible, so 17.5. And remember we said we were looking for a number somewhere around 17, probably a little bit bigger than 17, and that's exactly what we've got. Okay, so we can be asked to find mu or sigma or little x or little p. We've been asked to find mu. We know that we use the z's to do it. If we're going to use the z's to do it, we turn the x's into little z's. Okay, this number here is the value of little z which corresponds to this value of x. Now what I mean by that is that if we picture our x distribution is centered on some mu that we're trying to find. There is a value here where this area is 0.2, and this value here is 20. If I picture my z distribution, which is centered on 0, and it's not as spread out as this one, it's a bit more bunched up, because the standard deviation for z is 1, the standard deviation for my x is 3. There is another number which is here, the area is 0.2. That number there corresponds to the 20. What is that number there? If this is z and this is x, that number there, to translate from x to z, 20 minus mu over sigma. Okay, now you don't always have to picture these. You do just what we did when we did the example. You do 20 minus mu over sigma, and then you go for your calculator or you go for your percentage points table. Okay, but that's the key idea. If you're trying to find mu or sigma, you go for your z's, translate x's into z's, find the corresponding, that value there is the corresponding value to the 20. So 20 minus mu over 3 is the answer that the calculator spits out, or the answer that we get from the percentage points table, and then rearrange and solve the equation and get a mu out of it. Similar thing if we're trying to find a sigma. So I'm looking at the next example now, example 9. I've got x is distributed normally with 50 and sigma squared. So I'm also told that the probability that x is less than 46 is 0.2119. So I'm picturing this and I'm thinking to myself, right, okay, I've got a distribution here with 50. Probability of being less than 46 is 0.2-ish, so 46 is about here. That number there is 0.2. So one standard deviation is how much, I'm not exactly sure, but I know that 4 away from the mean, then the area here is 0.2. So I know that this area here is 80. So one standard deviation is somewhere near 46 because the area above that should be 84%, 0.84. So somewhere, so one standard deviation is going to be somewhere in the region of 4, right? So when I eventually go to the calculator or the percentage points tables or I work out my final answer, if I've got an answer which is 50, then I know I've made a mistake, right? So find the value of sigma. So that is, I've not been asked to find little x, I've not been asked to find p, I've been asked to find one of these two things, one of the parameters. I need to go for z's. Z, I need to turn this into a z, so it's a less than that little x value minus mu divided by sigma, and the sigma is just sigma, I don't know what sigma is. That 46 corresponds to this z value here, so that little x value corresponds to this little z value. What I mean by corresponds is the probability over here is the same on either of the distributions. Go for the calculator if you want. Remember you're in z's now, so sigma equals 1, mu equals 0, or see if you can find a table and look it up from the table. You'll notice that this 0.2199 is not in our percentage points table. So this one we almost certainly are going to go for a calculator, but if you had a bigger percentage points table with more values of p, can you imagine how you could use a percentage points table to do this? Perhaps you can. In any case, we'll go for a calculator. The calculator with the inverse normal distribution function will give us 46 minus 50 over sigma equals, and the value that we get out is minus 0.8. So what I've got now is that I've got an equation with a sigma in it. So if I times by sigma on both sides, I get 46 minus 50 equals minus 0.8 sigma. And then I mess around with that and solve it a little bit more, and I end up with sigma equals 5. And if you remember, we said we were expecting sigma to be about 4. So there's an example of finding mu, there's an example of finding sigma. So we now have the situation where if they ask us to find little x, we can bung it in the calculator. If they ask us to find little p, we can bung that in the calculator. Ask us to find sigma, we can do it this way. Ask us to find mu, and we can do it this way. And then of course what they do, once they've taught us a nice clear technique, they like to mess around with it. And one of the standard ways of messing around with it is in example 10, where they ask you to find mu and they ask you to find sigma. Now, have you noticed? So they give us an example where they haven't told us mu and they haven't told us sigma. So how do we deal with it? But look, finding mu just comes down to finding an equation with a mu in it. Finding sigma comes down to finding an equation with a sigma in it. So if this equation had a sigma in it and there was another one that had a mu and a sigma in it, then we'd have simultaneous equations with mu's and sigmas, and that's exactly what we do, right? So if you have a look at example 10, that's what they've done. They've got this information here, and we've got this information here and this information here, and we're asked to find mu and sigma. So we take this and we translate it into the world of z's. We take this and we translate it into the world of z's. So we should see 35 take away mu divided by sigma somewhere, and there it is. Look, that's that translated into z's. We should see 15 take away mu divided by sigma, and there it is translated into the world of z's. And then we find the corresponding z value to 15 minus mu over, well, sorry, we find the corresponding z value to 15, which is this. We find the probability value that goes with that, being careful to pay attention to the greater than or less than symbols and put it in our calculator accordingly. But essentially, we follow through the methods. For this fact here, we follow through the method from example 8 and 9. For this fact here, we follow through the method from example 8 and 9. And we're left with equation number 1 and equation number 2, which have mu's and sigmas in. We solve those two things simultaneously, and we are done. So that is everything on exercise 3E. Good luck with the exercise.